The universe, a vast, unknowable ocean of stars and galaxies, nebulae and quasars. But what if I told you that everything you can see, every planet, every star, every beautiful spiral arm, only makes up a tiny fraction of what's really out there? We are surrounded by mysteries, forces we can't see, substances we can't touch. And two of the biggest enigmas are dark matter and dark energy. Together, they make up roughly 95% of the universe. Think of it. Something invisible, yet profoundly influential in our lives. It's a cosmic ghost, shaping the very structure of reality. So, what exactly is dark matter? Simply put, it's an invisible substance that affects gravity. We can't see it, we can't touch it, but we know it's there because of its gravitational pull. Scientists discovered dark matter by observing the movement of galaxies. They noticed that galaxies were spinning much faster than they should, based on the amount of visible matter they contained. Something else had to be providing the extra gravity to hold them together. Imagine an invisible web woven throughout the universe. This web is made of dark matter, and it acts as a framework upon which galaxies form and evolve. Without it, the universe would look very different indeed. So, we've talked about dark matter, the invisible architect of the cosmos. But what about dark energy? If dark matter is the scaffolding, then dark energy is the gas pedal. Dark energy is a mysterious force driving the universe to expand, and not just expand, but to expand at an accelerating rate. This mind-blowing discovery came from observing distant stars, specifically Type Ia supernovae. These stellar explosions act like cosmic mile markers, allowing scientists to measure the expansion of the universe over vast distances. And what they found was astonishing. The universe wasn't just getting bigger, it was getting bigger faster than ever before. Here are a few mind-blowing facts. Dark matter makes up about 27% of the universe. Dark energy, a whopping 68%. That leaves only 5% for everything we can actually see. Stars, planets, us. And consider this. Without dark energy, the universe might have stopped expanding billions of years ago. Or even worse, it could have collapsed in on itself. So why should we care about these invisible forces? Because understanding dark matter and dark energy is crucial to unlocking the secrets of the universe's origin and its ultimate destiny. Could dark matter be a gateway to other dimensions? Are there hidden forces at play that we haven't even begun to comprehend? These are the questions that drive us, that push us to explore the cosmos and unravel its deepest mysteries.